Here is another great example of Monte Carlo simulation in Excel. It's based on problem 14 of your book. We refer back to the outsourcing decision model in example 1.4 of chapter 1. Basically, you're choosing whether to outsource or manufacture depending on certain numbers. So the outsourcing decision model is a spreadsheet implementation of the model. The model calculates the total cost for manufacturing and outsourcing. The key outputs in the model are the difference in these costs and the decision that results in the lowest cost. Note how the if function is used in cell B20 to identify the best decision. Now let's take a look at it real quick before we read any further. Here is the problem itself from the file outsourcing decision model. And basically we are given a fixed cost. This is a known number. This is the fixed cost of buying whatever machinery or stuff is required to do this. The unit variable cost, we are told, is 125. The unit cost is 175. And the production volume is going to be a random number. Notice that it is according to a normal distribution. So we use norm.inv to generate samples from a normal distribution, and we use the rand function. If you click in there, it'll tell you what it is for. The rand function is for the probability from 0 to 1. And then we know the mean is 1100 and the standard deviation is 100. And all of that is wrapped into a rounding function, which wants us to round to 0 decimals. That's why it starts out with round. So that will give us a production volume as a random number that follows a normal distribution with a mean of 1100 and a standard deviation of 100. As we look further down, we get to total manufacturing costs, and we see how that is calculated. You've got your fixed costs plus your variable costs times how many you make. Pretty straightforward. Now, if you were to purchase them, your purchasing cost would be different. Your purchasing cost would be the unit cost times production volume, or production volume times the unit cost if they are purchased from a supplier. So there's two numbers there. One if we make it in-house and one if we purchase it. And we're always going to be comparing the two. And if it's cheaper to manufacture it, we'll manufacture it. If it's cheaper to purchase it, we'll purchase it. In this particular instance that you see on the screen, the difference between manufacturing and purchasing is a negative number. So B16 minus B17 yields a negative number. Therefore, we should manufacture, since the cost for manufacturing with these random numbers is cheaper. So this is a simple function down here of, let's take a look at it, B16 minus B17. That's an easy one. And then we use an if function to put in the word manufacture or outsource. So the basic logic there is if B19 is less than or equal to 0, comma, in other words, if it's negative, then notice the quotations, put the word manufacture in. And of course you have to use the quotations there to get it to enter a text string. Comma, and then open quote, outsource, close quote, means that if it's not less than 0, then you would put in the word outsource. So every time this recalculates, and we can recalculate by going to the formulas, and there's a button over here that says calculate now, which is also F9. And I can hit F9 here. F9. F9 is being used for the software that captures the video, so I can't use F9. But if I say calculate now, it should recalculate. Come on, baby. There we go. So it gave us a new value, which also is negative, so it popped up the word manufacture. Now we're asked in the problem, let me go back to the problem so you can see how the basic layout of the decision is structured. Let's go back to the problem. Assume that the production volume is uncertain. Suppose the manufacturer has enough data and information to estimate that the production volume will be normally distributed with a mean of 1100 and a standard deviation of 100. Use a 100 trial Monte Carlo simulation to find the average cost difference and percent of trials that result in manufacturing or outsourcing as the best decision. So we need to come up with a one-way data table that actually produces two outputs. So let's go over here to a cell off base here, and let's start our numbers. 1, 2. Whenever you have a spreadsheet that has a lot of random number generation and recalculation, it's kind of slow because every time you do anything, it has to recalculate all those numbers. So I'm going to go down here until I have 100 samples or 100 iterations of that. So now we see the 100 that I dragged down to. And over here at the top of the table, I'm going to say this will be equal to the cost difference. Tab. And the one next to it will be equal to whatever it says in the box. And don't worry about the fact that they are changing as we make the boxes. Once we get it all figured out, it will still work. So, if the cost difference is minus 300, we will manufacture. That is the best thing to do, and notice that it says right there, manufacture. So if the cost difference is a negative 300, we will manufacture. Now if I hit calculate now again, it should recalculate. Once again, we would manufacture if the cost difference was a negative 8,800. Calculate again. So what we can do is we can once again run a one-way data table as follows. Select those three columns, Shift Control down arrow, so it selects all the way to the 100. Then we select data and go to what if analysis and select the data table. Now in the column input cell, once again we will trick it into recalculating all of the random functions by simply selecting a cell that we know will not change and has no impact on anything. So let's select cell B2. So it's just a blank cell. Every time that recalculates, it will give us a new value. So for every iteration here, we can see how many times we got the word manufacture and how many times we got the word outsource. And it looks like we're outsourcing fairly infrequently. So to be able to answer the back part of the question, which is to calculate the average cost difference, that's fairly easy. We would say equals the average of, from here, Shift Control down arrow to there, enter. And so the average cost difference for those 100 trials is a negative $5,085 for these 100 observations. Now the percent of trials that are manufacturing, we can use COUNTIF again. So let's do this. Let's say equals COUNTIF, open parenthesis. COUNTIF from here, Shift Control down arrow to there, comma, equals manufacture. Actually, I forgot the quote. You have to put a quote there. Manufacture. You got to spell it exactly as the way you expect it. If you don't, you'll get numbers you don't expect. Okay, so count if that range of cells equals manufacture. Close parenthesis. And because we want a percentage, we're going to divide it by 100. So we hit enter, and what do we get? 75%. And we can do a similar logic here and say equals count if from here, shift control down arrow to there, comma, equals, open parenthesis, outsource, close parenthesis, and divided by 100. Enter. Of course, this will change every time you regenerate the 100 random numbers. So with these 100 observations in this sample, 84% of the time we chose manufacturing, and 16% of the time we chose outsourcing. That's a clever little example of how to do Monte Carlo simulation, paying attention to the fact that Monte Carlo simulation tells us what happens over the long period. Long period of time, we're going to manufacture it in-house 84% of the time and outsource it only 16%. Of course, we know that if we go to formulas and we hit calculate now, and it will recalculate all of those values, we're still at 84.16. How about that? Calculate them again, we go to 87.13, but it's close. So we're able to make an informed business decision. The beauty of Monte Carlo simulation.